Okay, I'm sorry about the delayed start today. And the one more thing is, I wanted to bring your exam scripts to class today, but I couldn't finish them off. It took me too long to prepare the. I tried out two different code bases for today's class, so it took me too long in the night. That's why I couldn't finish this up. Anyways, from today we're going to start OpenGL programming, and I need you guys to work on your computer along with me to understand how you're going to set up the project so that you can replicate these things at home. Now, right at the start of the semester, what I did is I created a GitHub repository. Right now there's nothing in there. It's just a README and license file. Those of you who are already familiar with GitHub, it's a version control system. We can work in a team, and that's the idea for this course and some of the courses as well, that we can host our codes or share our codes within the team, and the team members, they can implement their parts and push their updates into the repository. I haven't added that feature yet. Well, you can create your own forks and work on that, and then send a pull request for me. The way you're going to get here is you can just go to github.com. If you have an account on GitHub, that's good. If you don't, then it's not a problem. You don't really need an account on GitHub to access these things, because everything is public. So what I want you to search for once you get there is just search for Summer 2017 CG for computer graphics. It's a single word, Summer 2017 CG. So if you search for that, once you get to GitHub, you will go to this repository. Says kmhasan /class -class /summer 2017 CG. You click on the link, that takes you to the page of our repository, and all the files that are hosted there will be listed down here. So what you want to do once you get there is that you can download the whole thing as a zip file. That's one way to do it, but the preferred way, or the way I'm going to show you, is you can just copy this. This is the URL to access all these things. Okay. What you can do after you do that is you can then write git clone and put that URL, and it downloads everything from that location. You have to have git installed on your system. That's one way to do it. But you can also do it from within your IDE. Like if you're using NetBeans, you can just go to team, git, clone. And this is where you can pass, if you paste the URL, you can get it downloaded through NetBeans. You don't have to know the git commands, although it's advantageous if you learn some git commands. But that's not something that we discuss in this course. If you need some help, I can always help you out aside the class hours. So when you download that, there won't be anything really. Okay, we don't have any projects, so we're going to create a project. Okay. And when we create this project, I want to do it a little bit differently though. Like previously, for those of you who are familiar with Java, in NetBeans you can just create a new project and say it's going to be a Java application. Or for those of you who have worked with JavaFX, FXML, you can go down to JavaFX and then create JavaFX, FXML application. You can also do Java EE stuff as well. There are many different categories to choose from. But what we're going to start off with is Maven. It's going to be a Maven project, and it will help us with all the dependency management. You see, we're going to do some graphics programming with a library called OpenGL. Okay. and that library has binding in many different languages. It has binding in Python, it has binding in C++, C, and also for Java. But to download the proper jar files and to manage the native files, it's going to be a bit of a problem if you have to do it all by yourself. In previous semester, that's the way we went, that we downloaded the zip files, extracted the jar files, and put them in proper place, and also put the native files in place. But that's a lot of extra work that you'd have to do. Things can be simplified a lot more if you can do it through Maven. Okay. So this time around, this is the route I want to go. This may not be familiar to some of you. Those of you who did Advanced Java will find it quite convenient to use Maven, and in some of the courses we also use Maven. So for some of you this may not be nothing new, but well, if it is, just try to bear with me and see how this can be quite an advantage. So we're just creating a Java application from Maven. There can be many different archetypes in Maven, but we're not going through that. And this is where you have to choose a project location, you have to give a project name and some extra stuff to start off with. Now, which section is this? This is section 2, right? Okay, so I want to maintain separate projects for the section, so I'll just go for project location, and as you'd see that we have summer 2017 CG downloaded here already. So do I have an option to create a, yeah, I do. So this is going to be section 2, and I'd rather put it as one word. And inside section 2 I will create this project. So this project to start off with will be called LWJGL demo. This LWJGL is a library. Let me show you what this is. This is lightweight Java game library. Okay. And we're going to use the latest release of that, which is release 3. 3.1.2 I think is the latest release. So we're going to use this library. Now this is for game development, and when you develop a game there are a lot of issues. It's not just about rendering the scenes, rendering frame after frame. That's not the only thing. You also have to manage events. How can you handle keyboard events or mouse events, or even joystick events for that matter. You'd also have to have a game engine. You have to have a audio counterpart to that, okay, so that you can play down the sound effects. With Java Game Library you can have all those features. It's not just about OpenGL, although I mean we are going to primarily use it for OpenGL, but you can develop a full-fledged game with this library. Okay. If I get a chance I'll show you how to do that for some simple stuff, for some simple games rather. So this LWJGL is one way to go about it. There's also another alternate called Joggle or JOGL. Okay, so it's a Java binding of OpenGL API. If you go to jogamp.org, this is where you'd find that there are quite a few libraries over here, and one of them is JOGL. We're already here. If you just go to the main page of JOGAMP, you see they have JOAL for audio library, JOGL for this OpenGL library, JOCL I don't have any idea about that. You could also go with that. I mean, these are two different libraries that implement OpenGL. OpenGL is a standard that's maintained by the Khronos Group, and there are many different companies that have implemented that for different languages. So for Java, we already have two pretty popular libraries. One is JOGL, the other one is LWJGL, and I've used them both. Like in some semesters when I introduced OpenGL with Java, I went with Django before. It's pretty good. It's just that they haven't had any new development after 2015, whereas for LWJGL is still in active development. So I'd rather go with that, and I find it a little bit easier to get used to initially. And the other thing is that I prefer LWJGL mostly for this reason, is that you'll find a whole lot of tutorials on setting up LWJGL and some relevant tutorials on YouTube, but not so much for JOGL. I mean, there are some guides. Well, yeah, it's self-documented and nicely. So I'm not really saying Joggle is bad, but maybe LWJGL will be easier to grasp for you guys if you look for references. So what I was saying is that for both these libraries, there's quite a bit of boilerplate code that you'd have to write, and the required jar files and also the native files, I mean, you'd have to put them in place. See, one thing, when we program in Java, we always talk about platform independence, right? That I write a code over here and I can run the same code. This is a Linux PC. I can take the same code. I don't have to recompile this. I can just run it out of the box on a Windows PC or on a Mac PC. That's possible because Java by design is cross-platform. Okay, and that's a very nice thing about Java. But when you try to bring in some external libraries, you can't really guarantee platform independence all the time. This one in particular, OpenGL, is a very nice example of that, because when you render something out on your hardware, it has to be very efficient. You don't want to wait, right? It cannot be software rendered. It has to be rendered by your graphics card. So it has to know how to interact with that based on your operating system. So you can't really ask for platform independence there. However, in Java, there is a very nice thing called JNI, Java Native Interface. Through that, you can actually make calls to C counterparts. You can write some programs in C, and you can call them from your Java program, and they will execute as if they are written in C. So that can be very efficient in that way. And for those of you who have some experience in OpenCV, it's an image processing library. They have the same thing. I mean, you have to make it efficient. So in that place also, you'd have to look for native code. So native code is very much platform dependent. We have a separate release for Linux. We have a separate release for Windows. When we run this code, you'd have to show that this is my native library. I'm not saying that this is extremely difficult to manage, but going through a dependency management system like Maven, things will be a lot less complicated. You don't have to worry about where to write these things when you run this, where to put those libraries. Maven will automatically generate all that for you. Okay. So first up, when we create this project, I'm creating it under section 2, and down here, since for some of you, this Maven thing can be new. This is where you create a group ID, and you have to write your company name in reverse domain order. So what that means is, let me give you an example. Let's say I work for Southeast University, and their domain is acu.ac.bd, right? If you go to www.acu.ac.bd, you end up to the landing page of Southeast University. So that's the home page. And that's for the World Wide Web. This is the home page. But if you go for my.acu.ac.bd, that's our USS site, right? Which doesn't really work because of some DNS configuration issues. But you can use my.acu.ac.bd from home. We know that. So this is the domain, acu.ac.bd. In Java, when we create a package or a library, we use the reverse naming order of the company name. So instead of writing acu.ac.bd, what I'd go is in the reverse order, bd.ac.acu. And after that, you put your project name. So if I create a lot of projects for Southeastern University, all of them will have the common part, bd.ac.acu, and then the project name. Okay. And this is where you put the version number. This is the 1.0 snapshot. This is not ready for release yet. We're just building this up. Once we're done, we'll just say that this is 1.0. So you can control version number as well over here. But right now, I'm not going to change any of that. So the only things that I've changed over here is the project name and the group ID. The rest is auto-generated. So I just hit finish, and that creates this project structure for me. So right now we see that there is a source package. As you can see up here, there is a source package, and there is one new thing down here. It says pom.xml, pom.xml. If you open up that file, and that's what manages all the dependencies for us, this is where every little detail about this project is written as an XML file. So right now it doesn't really say much, although you can see that the compiler that's going to be used for compiling this thing is Java 1.8, and that's what you're going to target for. You also see that the group ID, artifact ID, and the version numbers, they are all written out here. So later on, if I want to change something, I'll come back to this pom.xml and change those things there. UTF-8 is a character set encoding, how you're writing it. It can be 16 or 8, like depending on what Unicode you're using. If you want to support multiple languages, then you have to mention the Unicode. I mean, this is not just specific to XML. When you write HTML also, you can mention the character encoding. So then once we have this thing ready, I mean, if you run this project, it can't run because there is no class, there is nothing, there is not even a main file anywhere. There is no public static void main to start off with, right? So what we're going to do, we are going to create a new Java class, and let me just call this main with an uppercase M. It's going to be a class, and this is where we can throw in public static void main string args, and this is going to be our plain and simple hello world example. All right. If you run this project, now it finds out that there is a main class up here. So you can select the main class, and it starts to download all the required stuff from the internet. So that's the nice thing. Like, I mean, if you write a project on one computer, and if you go to another computer for development, if you go back home, and if you're trying to develop this project, maybe you don't have the libraries downloaded on your computer. But this Maven project itself will download whatever is required from the internet. It can be a bit of a disadvantage if you are not connected to the internet at home. There's going to be a problem because it downloads a whole lot of stuff, all that's required from the internet. Okay. You can create your local repository, but you have to make sure that all these required dependencies are met. So the first time you run this thing, it's going to take time because it's going to download all these required stuff from the internet. But once this is done, the subsequent compilation and running is not going to take much time. So once it has downloaded all those stuff, you can see down here, it says hello world because that's what we printed. Right? System.out.println hello world. So if I run this the next time, I mean, you don't have to download all that. It just says that it builds that thing, so whatever change you make, it will build it up, and then it runs that, and you get the output. So this has nothing to do with computer graphics yet. It's a simple Hello World Maven project. And leaving it just as it is, without doing anything else. I'm going to upload it to GitHub just so you can see what we are going to do with this. We will add this, we will commit this. Okay, so this is going to be simple Hello World Maven demo for now, and I'm going to commit this. And I will push this to our repository. Okay, so this is where I'm going to push it. I'm updating my code. So once this is done pushing, it might take some time because there is a whole lot of dependencies. Well, not so much. So then previously we had this license file and a README file. That's the only things we had over here. If I refresh this page now, you see that we have section 2, and under that we have a demo. So this is how we'll work in this section, or in this class rather, that any code that I write will be uploaded just like that. So what you can do when you go to summer 2017 CG, when you go back home, you can get all these codes that I've written. You can simply download them as a zip file, or you can take the URL, go to NetBeans, and then clone it from there. Once you have that, once you have it cloned, you don't have to clone it every single time that we have some new code. You can just go to NetBeans, and there is a nice feature. You can go under Teams, and then Remote, and you can pull. It connects to that repository, and whatever changes are made, it downloads only that part. So all these changes can be easily managed, and you can be in synchronization with the class quite easily in that way. Okay. In previous semesters, like maybe 2 or 3 years back, I used to use Dropbox sometimes Google Drive. I put my code there so that people can download from there. I also used Southeast University server to host those codes, but this is a whole lot easier to manage, and it comes for free. That's the other thing. So we have a main class right here, and like I said, it has nothing to do with computer graphics yet. It has nothing to do with OpenGL. The way we set it up, if you want to do it all by yourself, you'd go to JOGL. You can go to Downloads part, and this is where you see you can download a GitHub project from LWJGL and start working from there. But we already have our GitHub project, so I don't want to download from there. Right? I have started a project. How can I incorporate this OpenGL stuff, this LWJGL stuff, right from there? So you'd have to choose a release from here. So this is the latest official release, 3.1.2 build 29, but the stable release is 3.1.3 snapshot. And there's also a nightly version. The nightly one is the continuous development one. So you can't really depend on that for any production code. If you want to really use the latest stuff, you go for the nightly build. If you want to rely on the official release, which they have properly tested and they can certify that, I mean, this is more or less bug-free. There can always be bugs, but I mean, this is properly tested. So you can go for the green one, the release version. And like you see that the dates of the releases are given. This one was published in May 15th, and the nightly build was just updated 2 or 3 nights back. Okay. So I'll just go with the release one, although at home I tried with the nightly version. So if it doesn't work, I'll fall back to the nightly one. But I mean, this is not going to be difficult. Once you go to the release, what I want you to do, you can download it as a zip file, alright? All these files will be there. However, since we're using Maven, we can pick Maven from here. And for those of you who are familiar with Android Studio, there's also a dependency management tool in there. We use Gradle instead of Maven. We use Gradle. That's also a dependency management system, and they can work with the same repository. So for now, I'll go with Maven because that's what I started off with. And down here, you'll see that there is a script generated for you based on the things that you have selected, the stuff that you want with it. You can, for example, if you don't need the audio component, you can just uncheck this, so it won't be included. But for now, for simplicity, I'll just say that I'll take everything. Okay, it's going to be slow, like it's going to download a whole lot of things. But if you know already what are the things you need and the things that you don't need, you can clearly say that these are the things you're going to pull from here. So I'm going to take everything from here, and you can just click this button over here that says copy to clipboard. What it essentially does, it copies this part, this script part, but which you can also do by selecting the whole thing and pressing Ctrl+C. So nothing new there. So copy that, it says it copy to the clipboard, you go back to your project, and over here you see that there is a POM XML, and that XML script goes inside this POM XML. Okay, so what you can notice is that the properties are already defined over here, right? This is the properties defined, and we already have a properties section right in here. So what we are going to do is we are going to get rid of that, and along with the properties there are some dependencies that to compile a project with LWJGL3 you need all these things. Okay, I will go through some of these things in subsequent classes, but not for today. For today, I just want to get started somehow, that we want to show, let's say, a cube or a rectangle or a circle or something. So I'll explain some of these things, not the whole thing though, but for now, let's just say that we're going to replace this properties part with whatever we grab from there. So all that thing, Ctrl+V, you paste it, and they all come down here. So right now it's a whole lot of things. And then you can do Alt+Shift+F to format it properly, and you can do it for your Java code as well. It's a pretty handy feature. For example, let's say I put in a lot of tabs over here, some tab over here, maybe this is not aligned right. Okay, Alt+Shift+F fixes all of that. Alright, so once we have all the library set up in our POM XML, the next step is to just compile this thing, just try to build it once, and there will be some issues while building this thing. It may not be on this computer. On my computer I did have this issue, and that really took me quite a bit of time to fix, which is also a reason why I couldn't sit down with the exam scripts and get them done. So it's downloading all those library stuff from the Maven repository that's hosted for public use. You can download them, and all the native jar files that we need, they're also getting downloaded at the same time. So yeah, well, I'm facing the same problem over here, but at least I know what to do right now. So if you take that, all those script generated stuff and put them in your POM XML, you'll run into trouble, at least on Linux. Maybe not on other computers, but on Linux you'll run into trouble because it cannot find that LWJGL-OVR in the Maven repository. It's not there. Okay? But in our POM XML, it says that you need those things. So what you can do here, you can search for those OVR specific things. I don't really know myself what these OVR stuff is needed for, but what I've seen from my experience is that you can run your code pretty good without that thing included. So I found out one OVR instance over here, and I can comment out this part. Do we know how to comment out any XML or HTML thing? Yes, no. Like in Java code, we know how to comment out a line, right? How do we do that for HTML or XML? Like that? No, not really. Right, so this is how you comment out something, and we don't need that for now, so I'm just commenting this out. I'm going to look for any other OVR instances that we have over here, and we can comment this out. Well, the same strategy, or you can use the IDE to comment this out. Control-Shift-C on NetBeans comments out certain sections, or it's actually a toggle thing. Control-Shift-C gets it back. Control-Shift-C comments it out. Alright, so these are the only two things where you had the OVR stuff. So let's try to compile this one more time. At least this time around, it didn't complain about not finding the OVRs. It's still downloading a few things. But the good thing is, it says build success. So it successfully built the whole thing. And we can play it just to say hello world and nothing more. Still, it doesn't do anything with computer graphics, but at least we have all the required libraries properly set up. Can you guys follow this? I'll for sure upload the code that I have done over here in a bit. Once we have a window created, I'll upload it there. Now, we got the script from LWJGL site, right? It has a bunch of stuff that you'd need from time to time. One of them is obviously how to get started, and it gives you a base code right in here. So it's a simple Hello World project that creates a window and shows it to you just like that. It's going to be a red window if you follow the code. Now what I'm going to do is that I'm not going to copy the whole thing. I will only take the required parts and put them in my code. So this is my main class, and I want to leave it just like this. And, I will create a separate class. It's going to be a plain Java class. I will call this renderer. Okay, so it's going to be slightly different from their getting started code. They have a Hello World project, and I just want to call this a renderer. A renderer, the idea is that it's going to render something onto our monitor. That's the purpose of this class. Okay. However, in this class, I will follow their convention in a way that say that there will be a method called public void run, and there can be a constructor if you need something to get started with. There will be a constructor. So the idea over here, instead of saying hello world, what we are going to do is we are going to create a renderer object. Okay, so we are going to create a renderer object. And after that renderer object is created, we'd say renderer dot run, and it will run to show us the window. It will show us the other stuff, whatever is going on inside that window. Okay, that's the idea. So inside the run method, when we are running this code, there's some stuff we will do only once to initialize. And those things will be put in an init part. So I'll call init, and there will be another thing that will be run in a loop. So I'll call init, then I'll call loop. I'm not going to call this loop method inside a loop because the idea is that this loop method itself will keep on running till I close this window. And this is the idea, even if you don't call a loop method by yourself, the idea for any graphical user interface based system, for example, the IDE itself, has an internal loop because it shows us this window that we see over here. Otherwise, when our task is done, it will simply die down. It will finish, right? But we see this window constantly being rendered. You see the cursor is blinking over here, so it's a continuous animation. It needs to be there. So someone internally is running the loop, and we see this. Okay. So I'm just calling two different methods. One is for initialization and one for loop. They don't do anything because I haven't added any code in here yet. All right. Now, to start off with, I want to tell you that we are working with OpenGL, that's fine. But OpenGL only provides you the functionality to draw stuff. Okay? It pretty much draws stuff on nothing. Now, by nothing I mean you yourself have to provide us the context where it needs to draw something. I have to provide the window, I have to provide the key listeners, the mouse listeners. None of these are done by OpenGL. OpenGL only knows how to draw. So if you are familiar with JavaFX, that's a windowing toolkit where you can create windows, you can add some components like text fields, labels, all those stuff. But JavaFX is not the only choice. You can also go for Swing. There are other alternates that are more cross-platform. For example, this JavaFX, there is no equivalent part of JavaFX written for C++. I'm not saying that you cannot do graphical user interface based systems with C++. You definitely can. For those of you who have used CodeBlocks, it has a really nice set of GUI building tool called WX widgets. You can also use GTK for that. You can also use Qt for that. There are many different libraries that you can use to build graphical user interface in C++. But those things are again not available to Java. For example, WX widgets is not available for Java. This JavaFX is not available for C++. So if you want to get something cross-platform, you have to choose from that set. Now for OpenGL stuff, there are quite a few choices, and the ones that I've tried myself, one of them is GLUT, Graphics Library Utility Toolkit. It's not being developed anymore, so far as I know, and GLFW is another choice. So over here, I don't really have a choice really. For LWJGL, they're tightly bound with GLFW. It's a windowing toolkit. So the idea is, right now, I'm going to use GLFW to create a window to handle the keyboard events and everything else. I mean, I could do it with JavaFX, but to hook up JavaFX with LWJGL takes quite a bit of hack. I mean, it is definitely possible, but I'm not going to go that route. I want to keep it simple, and that's why the windowing toolkit of choice is going to be GLFW. I mean, for those of you who have done Java with JavaFX, you know how to use Scene Builder to build a scene. You're just not going that route. It's going to be a different library. It's called GLFW. But right now, to start off with, I want to see whether things are working. So right in it, I want to just do a printout to see what version of LWJGL am I using. Do I have things done right? So there is a class called version. Okay, I need to import this, and this version class is available in a whole lot of packages that may not have any relationship with what I'm doing. So the one that relates to me is coming from LWJGL. It's down here, the second option. So import from org.lwjgl.version. There goes that line. And how you can print this out, so you can say system.out.println version.getVersion. It's a static method, so you can just use a call by the name of the class. So as you notice that from the run method we call init, so the call will definitely come in here, and we're going to just print this line. And from the main method we have created a renderer object. We are running this thing. So it says LWJGL version 3.1.2 build 29, and that's what we started off with. When we went for download, see, the release version is 3.1.2 build 29, so things are in proper place, and at least it is running, right? Okay, so far so good. And this is the time, I think, since everything is in place, I want to push this code to GitHub, and I want you guys to download that on your PC. So whatever I'm adding to this code, I want you guys to add it with me so that you're familiar with this thing, and at least you know already that you can download it and run it on your computer. I want you to have that feel. So from my end, I'm just going to add this, commit the changes, and I'm going to push this to our repository. So it's doing that. It may take a bit of time to push it with all these dependencies. It has a lot of jar files in here. Yeah, thankfully internet is not as slow as it was in the last few days. So if I refresh the page, it says that the last update was done 30 seconds ago. That's when I did my commit, and then I push the code. So if you go to this repository, you can see that there are two files now. The renderer is also added. For you though, like when you need to download all these things, you can just go and download the zip file, or you can just grab the URL and download it through NetBeans. Okay. So let us take 2 or 3 minutes. Get the project downloaded on your computer. Open it with NetBeans, and just run that, and let me know whether you see this output. Yeah, if you can successfully run this, let me know. So I'm gonna wait on that. মানে গিটহাব থেকে নামানো তো আসলে শুরু থেকে দেখো এইখানে যাও, এখান থেকে গেলে তো ডাউনলোড করতে পারো। এখানে সার্চ করলেই হবে। আমার 2017 একশো। এটা নাও, ক্লিক কপি কপি নাও, আর নেটফ্লিক্সে যাও। করে দেখো টিমস, এখানে অলরেডি ওপেন করার প্রজেক্ট আছে, ক্লোজ করে দাও, ফাইলে যাও, ক্লোজ অল প্রজেক্টস। একটা জায়গায় ওনার ছিল ফোল্ডার ডাউনলোড করছে, বাসে যখন ডাউনলোড করবো তখন লোকেশন দেখে নেব। এই যে প্রজেক্ট আসলো, খুললে পরে ডাবল ক্লিক করলে পরে খুলে দেখা যাবে জিএস। প্রথমকার যেটা করবো সেটা হচ্ছে বিল দেবো, যা যা লাগে সেগুলো সব কিছু ডাউনলোড করতে শুরু করলে, তারপর প্লে দিলে পরে তখন মেইন ক্লাসটা ক্লিক করতে হবে। All right, so this had nothing to do with any graphics rendering. It's just giving you one output. And now to get started, we need to create a window. We need to draw inside that window. All right. So the way we do that, to create that window, before we get there, we'd have to do a GLFW initialization. It does all the things that are required by GLFW before it creates the window. Okay, so GLFW is a class written in all uppercase. It has some static methods, and one of those static methods is GLFW init. Okay, it has to be called once. So if it's not initialized properly, you'd have to throw some exception and report the user that cannot be done. So if not GLFW init, you can just throw some exception. So that's the thing, like why do I have to do that? Okay, that's because it's a exception class. They have used some other exception. Okay, so I can do runtime exception. Right. Illegal state exception, rather. Alright, so there are two types of exceptions. Some of the exceptions are runtime exceptions and some of them are errors. So the idea is that you'd have to catch all the classes that are exception or subclasses of exception. The runtime exceptions, they don't need to be caught, but they can be thrown. So there is no problem with initialization. That's what we see here. So the next thing we're going to do here is we'll say glfw dot glfw create window, and this is where you see that we can specify the width of the window, the height of the window. We can also put a title on the window, and there are two more things which we are not going to use right now. If you have multiple monitor, you can actually specify which monitor this thing will be placed on. And I can't really show you here because it's a mirror reflection. Like these two monitors, I got two displays attached to this computer, but I can't show you the difference because these things are mirrored. It's basically one thing right now. But if you have multiple monitors in your setup, you can actually specify which monitor it's going to go to, and you can also indicate it whether it's going to be shared or not. For now, this is not going to matter for our scenario, so we'll just deal with the first three parameters. We'll say what's going to be the width of the window. So let's say 800. I'll go with a square size to start with, but you can pick any dimension as you want. You can also go full screen, but I mean that's something I'm not going to do right now. So LWJGL demo, let's put that as a title, and these two, let us just leave them as 00. And if you do that, it creates a window, but we don't get to see the window. Alright, it creates the window and it vanishes right away because there is nothing that stops it or keeps it there. Okay, this is where we have to say that I want to show the window to the viewer, and even that is not going to stay right there. See, it needs a number. What's the window number? We can create multiple windows and we can say that I want to show this window. I think I have showed you guys that you can have multiple windows of an application before. Like for Blender, you can just say duplicate window, so we have two windows for the same blend file. And you have already noticed that maybe in your browser you can create a new tab or a new window, right? So that's the idea, that in our application too, we can create multiple windows, so we need to tell this application which window to show, where we're going to draw. So those things have to be very specific. Now, in order to do that, we have to give a number to the window that we created, private long window. So we have created a window and we are trying to show that. Let's see if anything changes. Yeah, this computer is pretty fast. Like it does create a window, it shows the window, but it goes away right then, and we don't even get to see that. And that's the point, that when you go into the loop, it's the job of the loop to keep it in place. And if you look at their code, see, it shows the window just like I did. Well, one thing I did forget to add is to make the context current. The current window should be that. We have to tell OpenGL that bit. So let me add that one which I missed. So this is going to be the current window, and just to run this one more time, yeah, we still don't get to see that. So we showed that thing, like the window is shown, but we still don't see that because it goes away right at that time. But in the loop, that's what we do, that we we run a loop. See, this is a loop that keeps on running, and this is where we can draw our stuff. So we have this set up, and this is a very bad practice, but let me do it anyways. While true, this is going to be an infinite loop, and this is where we will write one thing, glfw dot we're going to swap buffers on the window. I'll explain this one. And one important thing before I forget to mention this, we need to create the capabilities. What are the things that we can do with OpenGL? See, OpenGL has multiple versions, and it's not always backward compatible. The current release, or the current one is probably 4.5. So the way we write OpenGL program these days are quite different from how we did it for version 1.1 rather. So back in the day when I learned OpenGL, the stuff that I learned with something called fixed pipeline, it's totally gone now. People don't write code in that way. They try to take advantage of the GPU, and it's all shader based. We're going to move into that, okay? But not in this class. It's a little bit complicated to start with, but it really adds to the performance. So first of all, you need to call this method to ensure or to see what are the capabilities of your graphics card, and you need to see what OpenGL version you have installed at home. If you don't have one of these modern cards, I'm not saying you have to have GTX Titan or the latest ones that are out there in the market. You don't need that, but you need to have something of like NVIDIA GeForce 600 series, anything of that nature. Okay. The ones that we have on these computers are pretty good. It's 960. We got 2 cards on each computer, so that serves the purpose. To know what version of OpenGL is installed on your computer, you can just type in glx info, and that gives you a whole lot of information, and you can't really go through that. So you can throw that into a pipe and say grep OpenGL. So that brings out the OpenGL specific stuff. See, the core profile version string is 4.5. That's the version of OpenGL we have installed on this computer. And it also tells us what's the driver that we're using. I've only tested the codes that I've written on NVIDIA cards, but they should also work on Radeon cards as well. It's just that I don't have those cards anywhere, not at work, not at home, so I can't really test and see. So if that's what you have at home, well, try it out. Try to find out your OpenGL version. Try to see whether your code runs or not. Now the code that we're going to run today, they will definitely run, no problem at all. They shouldn't cause you any trouble. However, when we go into shader-based programs and you don't have a proper driver installed, then those codes will not run. Okay. Well, it can, but I mean, we're not running anything CUDA specific. The codes that we're going to write here, they will run on the GPU. Not today's code, it's going to be on fixed pipeline. So today's code is still based on old OpenGL, but I want to move on to shader-based OpenGL. They will run on GPU, and they can take advantage of CUDA. However, we as programmers, we don't necessarily have to write programs on CUDA. It's not our burden. The library itself will manage that. That brings us to an important discussion though. Like, CUDA itself is a very powerful library. You can use it for other purposes than computer graphics. You can use it for parallel processing, because on your graphics card there are a lot of CUDA cores, parallel processing units that you can use to boost up your work, whatever you're doing. You don't have to always rely on your CPU, right? Because there are some other processing units sitting right there. So we can take advantage of that. But that's not something we need to be worried about, at least in this course right now. So, so yeah, like the thing that I've done over here inside the while loop, see, I'm calling glfw swap buffers. Have you guys heard about a term called double buffering? Um, when you buy a graphics card, if you go through the specifications written on the box, you'll see there are a lot of things mentioned, and it has those terms like triple buffering, double buffering, those things. It has a lot of things about texture mapping stuff. Um, so the concept of double buffering is quite important to understand. You see, in computer graphics, we need to render things really fast. Otherwise, they will not look nice. Like, I mean, if you have a frame, if you have to wait for a bit, if you blink your eye and you find the next frame, you won't find it pleasing for your eyes. Okay. If you have a choppy frame rate, if it's lagging, then it's going to be bad. So what we do when we render stuff, we show something on our screen, and in the background, we prepare the next frame. Okay. So one frame is shown to you, and the other frame, when we are showing that frame, the other frame is auto-calculated, not auto-calculated like it's done through some process, but it's put on a second frame. So what happens, the next time I need to show the second frame, it's already ready for me to process. We just swap the buffers. So the one that's behind comes in front, and the one that I was showing, it's all memory, it goes back, and we write to the stuff that goes back, we prepare the next frame, and then we swap it again. Okay. Two things are prepared at the same time. One you see right now, and one is in the background. So the background stuff is being auto-calculated while you look at it, and then when we're ready, we just swap it. So that's actually faster, because if I had only one frame to work with, or one buffer to work with, I would prepare everything, write everything over there, then I show it to you. Then for the next frame, I'll have to calculate everything, put the stuff in the buffer, then I show it to you again. So there is a pause. With double buffering, that pause is gone, because we can just swap the buffers and you just see it just there. So this is going to be a very bad practice the way I've written this, but this should at least bring the window right in front of you. The window was there before, it's just that we couldn't see it before. And yeah, I mean, that's why we said that. I mean, I said it was a bad practice. The window's there. This program crashes because it's not responding. It's continuously waiting in a while loop. It's continuously just swapping the buffers and doing nothing else. So I'm going to force quit this. Okay. One thing you need to do along with swapping the buffers is you have to poll for events. You have to see whether you have some keyboard events, whether you have some mouse events. Okay, you have to poll for events. Polling events is just making a query to know whether there are any events waiting for me. Okay, and we can't really run this thing continuously. I think this one should go first. First of all, well, actually no, the other way around. So you poll for the events, and when you run this while loop, you can't run this independently. There is a nice method in glfw. Window should close. You're asking whether this window should close. Okay, and the window number is the one that we are maintaining over here. While this window should not close, do the following. Swap the buffers and see if there is any event waiting in queue. Is this idea clear? Let us try this out. We have this window. It's an 800 by 800 window that says LWJGL demo right there. We don't show anything, but when we cross this off, that's an event. You want to close this window, and that when you pull this, we got this event, and we tell that yes, the window should close. So this becomes false, and you come out of the while loop, so the program ends gracefully. Is this thing clear? All right, so this is where we do the loop, and I want to write another function, or method rather. let's say this is our draw something method. It's not a nice name to say. It doesn't really matter at this point. I just want to draw something. That's the idea. Alright, so my drawing code will be over here. And like I said, I'm going to use old OpenGL stuff. First of all, before drawing something, I need to erase the whole window so that I can draw right now. So the code for that is GL color. GL clear. I want to clear. Then I have to tell what do I have to clear. So first of all, what you'd notice, I have written GL11 or GL11. This means this is OpenGL version 1.1. The more recent one, for example, if I want to use something from OpenGL library 4.5, then I'd say GL45. That's the idea. So GL clear, this is where we'd say GL color buffer bit. It's a defined constant. There are a lot of things we can clear. For now, we are only clearing the color buffer bit so that we can draw with the new colors or whatever we need to draw. We can also clear depth information when we are working with 3D stuff. But for today's discussion, we are not going into 3D yet. I mean, to start off with, it's all new stuff. That's why I want to go a little bit slow. Yeah.
Does the GL11 create a new library for this?
Well, no, like you have all these capabilities. I mean, your graphics card is capable of handling many different OpenGL versions. So one of those versions is OpenGL 1.1. So we are just using that version to clear that. And the new versions, they also have a clear thing, but we can just get the old version to clear it out. Some of these things that I'm going to use today are deprecated. They're not available even. Like in Java, when we mark something as deprecated, they're still available in the new releases. But for OpenGL, the stuff that I'm going to do now, we can do it with GL 1.1, but not in the latest releases. They're just taken off. Okay. These are inefficient stuff, so you don't use these things anymore. Still, it's a good start. It's easy to relate to, and these are stuff that will relate to our transformation stuff that we just covered a few days back, like day before yesterday. We were talking about translation, rotation, and scaling. We looked at a math background, and those things will be quite important right in here. So we clear this thing. I mean, but you can yourself specify what's going to be the clear color. Okay, and this is where you pass in RGB A values. Red, green, blue, and alpha. They're all floats, so the range is not from 0 to 255. The range is actually from 0 to 1. Okay, so 1 for red, 0 for green, 0 for blue, and 1 for alpha. I want to make it opaque. It's going to be red. So if I run this thing, you'll get a red window. All right? And if you want to see a yellow window instead, 1 for red, 1 for green, you run this thing again, you get a yellow background right in here. Okay. And if you put 0, 0, 0 for red, green, and blue, you get a black window. This is the default. All right, so you can play with the colors to set the background color. Is this clear? Okay. So let us quickly draw a simple square right in here, and that would be it. I know that I'm going over time, but at least I want to have this thing in place so that when you run this code at home, you see something. It's not a blank thing. So GL11.gl begin. I mean, this is how we did in the old days. We start for something and we say, what do we want to draw? We want to draw quads, quadrilaterals. Okay, those are polygons with 4 sides, if you don't know the term. So it's like HTML. You begin something, you end something. All right. So we want to start drawing something. We are going to draw quadrilaterals that we have said, and this is where you have to tell what are the vertices of that quadrilateral. GL vertex 3F tells us that we have to create a vertex, and 3 says that we are going to provide 3 coordinates, x, y, and z, and all those coordinates will be if. If stands for float. You can also pass integer coordinates. So for now, we're going to pass in floats. And let me go with something simple. -1, -1, 0. Well, just to show you what I'm going to do. See, I want to draw a quad like this. This is 0, 0, right? This point is -1, -1. And then this is +1, -1. This is +1, +1. Yeah, I'm just putting the signs just to make things clear. And over here, this is -1, +1. Okay, I want to go counterclockwise. So I'm going to start at this end. Okay, so this is the first vertex. The next vertex is going to be +1. So we got 4 vertices. Remember, we got a black window, right? This is saying this is the black window, and now we are going to draw a polygon. By default, that polygon is going to be drawn in white. See, over the black window, now we have a white square. And it's covering the whole thing. That also tells you that we're going from -1 to +1, -1 to +1. So if you change stuff over here, let me replace those just to make sure that we have this. Let's say for all these ones, right? We want to change that to 0.5 float. Shoot. Right. I forgot to put the comma. So I want to do that. What's going to be the difference? Instead of saying from -1 to +1, I'm just doing from half the width, half the height. So can we see this? And if you understood that this is how all these things are laid out, you can also play with the color of the quad that we draw. You can just say gl11.gl color 3f, and you can create your own color. Let's say I want to make it yellow. So just as we have seen before, 1 for red, 1 for green, and 0 for blue makes it yellow. And that's going to be our yellow square right there. Is this thing clear? So this is how we write the code. And just to make things interesting, let us start rotating this thing. We know how to rotate, right? We know how to do it in Blender. So why not do it over here? So this is the reason we have a push matrix. I will explain it in next class. That's not good. So we're going to push the matrix and we're going to pop it. It's very closely related to what we have studied in the class day before yesterday. We defined matrices. We defined the transformation matrices. So it's very closely related to that, but I'm going to explain that in our next class. What I want to show you quickly though is that we can rotate gl11.gl rotate if, let's say I want to rotate by a certain angle, which is given by a a variable called angle, and I want to rotate over the z-axis. X equal to 0, y equal to 0, z equal to 1. So this says that I want to rotate on the z-axis, and I want to rotate by some certain angle. What's that angle? I will define it over here. Right, initially the angle is at 0 degrees. This is in degrees, by the way, not in radian. So every time we draw something, we want that angle to increase. So this is being drawn, right? We call draw something, and the angle gets, increased every time. So when you run this code, this is what you get. Z-axis is coming out of the board. X goes to the right, Y goes to the top, and Z is coming out of the board. So this is how it rotates. And yeah, I mean, that's a good question too. Like if you want to try for other axes, let's say I want to rotate it around the x-axis. See if you can relate to this. X is this axis, right? You're looking at it from 2D angle, so it's rotating like this. And if you change it to y-axis, this is how it rotates, right? So for now, I'll leave it at z-axis, or you can make a combination out of the whole thing, but that's not needed right at this point. But yeah, we can draw this. So I'll probably spend one more class on this old OpenGL to draw some primitive stuff. Maybe we can make an analog clock right in here with simple animation. You can actually build a full-fledged game with the old OpenGL stuff even today. But it's just that it's not efficient and there are better alternates, so I want to move into shader-based OpenGL. What I want to get a feedback of though, like when we start shader-based OpenGL, you should be able to run them on these computers for sure. These have new cards, but if you run into trouble at home, I'll ask you to spend more time in the labs then, for those of you who run into trouble. Because I can't really ask you to buy a new graphics card for this course only. Alright, any questions so far? I'm not going to add anything new. I mean, this is as far as I wanted to go, and fortunately things have run properly, at least on my end. Try to make sure that you can run all these codes on your computer, whether it's Windows or Linux. It shouldn't be a problem. So we have a rotating square, and that's our work for today. And I am going to push that into a repository, and once you go back home, you can download it from there. Actually, or you can just go for team, remote, and pull and download it on your computer over here and see if this is running. So yeah, just to make sure that we got everything in place. Yes, everything is uploaded properly. All right. So please try to make sure that all these things are running at your end. That's what I'm stressing on.